So I see everybody's still probably either asleep or sleeping while sitting here. I know, are there a lot of people still coming, or should I just start? Otherwise I'll just get going. Okay, I want to talk about this morning a bit about data objects. What does it do? What's the goal of the project? And where do we want to go from here? My name is Dirkjan Bussink. I've been doing Ruby development since about 2006 professionally, and I've contributed to a bunch of open source projects like Rails, Burp, Rubidius, DataMapper, and also DataObjects these days. I work for a Dutch company called NetApp. I just put in the picture because it's a really nice, cool picture of our office, but I'm not going to talk too much about it. And, well, before I start, I want to do something. Okay, I want to do something different. I want to start up because I know quite a few people are still maybe not really awake and had a rough night last night. So I just want to start with a little bit of exercise. We're going to do a little warm-up this morning. So I want you to go on with, is the sound just, it's continuously dropping. Okay. Okay, that's really technical difficulties. Is it? Yeah, otherwise I'm going to skip this because, well, there are not a lot of people here anyway. I'm going to try one more time. Okay, I'd like to get people to the first move we're going to do is close the laptop. And is everybody, oh. Which one? Oh yeah, I could do that.
Just to make a test.
Okay, okay, yes.
Yeah, so they are going to double check that.
Okay, all right. Yeah, I can just probably just skip it because I had a nice morning exercise for everybody in the room, but since the music is not really helping, I'm just going to go through with this. Anybody could do this, by the way. I'm going to buy them some beers. Okay, so we just go on to the really more boring stuff. Actually, DataObjects is about old school, old style database systems. It's not about the fancy new stuff like the SimpleDB, the Amazon SimpleDB, CouchDB, or whatever. It's really back to the old database. And the question could be, why would we want to do that? Because, well, this is like in existence for years, and it's not necessary anymore. Oh, it's okay. Oh, no, it's I don't need it anymore. Oh, okay, it's okay. And one of the big questions always is why would we want to do this? Because, well, there's the common knowledge of do not reinvent the wheel. There are databases that have been used in Ruby for years and years, and every database has their own way of doing stuff. So when the DataMapper project was started, one of the things that was a problem, we didn't want to have different adapters and write different code for each database and just have a uniform API. So we didn't want to have a car that looks like this with a square wheel, a huge wheel, and a normal wheel. Just want to unify the system. Because if you look at how it is with existing adapters, I've got some short layout here. You see 4 different adapters. On the top there's the MySQL. It has a real connect method. I don't know why they don't have the I think historical reasons they don't have the connect method anymore, so now you can really connect to the database. You can execute a query and get the data back, and you get an array by default of objects. In Oracle, it's kind of the same, but it's slightly different on how to make a connection, how to execute a query, and how to get actual results from that query. If you look at the other step, there's Postgres, which has yet another form. What you can also see here is like the arguments, the order of the arguments and the types of the arguments is different. Sometimes you have to give it the port first, or the user, or the database, or whatever. And you see here a SQLite, which has even a different way of, it's not even looping through a result, you just get a huge double array as a matrix with the actual result. But like Mats already talked about, it's all about the API. It's creating a way of making it easier for programmers to work with your system. And this wild growth of all kinds of different approaches really was creating difficulties, because in the DataMapper project we want to keep the code simple and clean and don't want to clutter everything with, okay, this is a Postgres adapter, so we do it this way. For SQLite, we do it this way, or whatever. So actually what was designed was as a new API. I'm going to show some examples of it. So here the first thing is how to create, for example, the connection. The connection is created by a uniform URI that actually looks kind of the same for each database. There's always room for options in a URI, like what encoding should we use? Should we use additional parameters, maybe SSL certificates when connecting or whatever? What you see next is you can create a command. Command is just a SQL statement, and here we see a simple insert statement. The insert statement is a DDL statement, so it's not a querying statement. It's actually changing your data. So what you there use is you use the execute non-query, which actually gives you a result back that conforms to how SQL works. That's basically, it gives you how much rows have been affected, which is actually the standard SQL result for an insert. But what you always often see, and what's really useful, is actually retrieving what was inserted. So you can do both. Here you also see that this tries to abstract away from the specific implementation of the database, but it can't do it always, because you have situations, for example, with Postgres, where you have another syntax to actually return the inserted ID. So besides, of course, inserting data, there's also the possibility of retrieving data. And here you see another feature of DataObjects, which is not common in other database drivers. What you see here is the select query that's been executed, and there is a table with at least 3 fields here. We have an ID, which is an integer, a login, which is a string, and a created at, which is a date object, a SQL date object. So what you see here is I execute a reader command, and it actually shows me, okay, what columns are returned in my result set, and how can what can I do with them? And if you here you see I have the reader, and you can iterate through it. It's just a cursor moving forward, so it doesn't load up all data at once. It tries to be smart and only keep the current results for the current row in memory. What it also does here, what you can see is I kind of made some semi-coding syntax here to show that if you look here at the values for this row, you see here, for example, here it's 1. That's the ID of this user. The Bussink, that's the name of the login of the user, and you see here a date object. So the date object in the database is actually turned into a Ruby date object when retrieving. This has some advantages, for example, like it's something that is done in, for example, Rails itself, and this is a lot faster because this happens low level in the C driver, which actually parses the date because it has a known format, and it can use fast parsing functions and not, for example, date's been parsed, which is actually horribly slow. So what you just saw is typecasting. Of course, it's not always the best solution you want, so you can, of course, do whatever you like yourself. So what you can see here is, you can see, actually I'm running the same query. Oh. Oh, okay. I can just, oh. Just take that off. Okay. So, let's see, where was I? Okay, yes, custom types. What you can do besides the default types, which it tries to infer from your database, is you can look and set the specific types that you want to be returned. So here I'm actually running the same query, but I say explicitly want 3 string objects back. So that allows, for example, this case, you see 1 as a string coming back, and the date not as a date object, but as 2009-5-10. You can also put in types, for example, that are, if you, for example, have a string column and you want to say, I want to try to parse it as an integer, you can do that, and it will give you like the standard behavior of the string to s Ruby function on a standard to I function on a string behavior. Okay, the next step here is parameter binding. DataObjects support parameter binding for all adapters, and it uses it all in the same way with the question marks. The question marks identifies where can I put in a value. Here, for example, you see I want to look for a user with a specific login, and I retrieve it here, and I see I made a typo there. I didn't replace the password. But what you can see here is I just want the user with the first parameter that I was set, the first question mark, with the user here as a login of Bussink. This is currently done by parsing in the driver itself, but we're going to move that also to using the native parameter binding of the, for example, the C drivers or the JDBC backend, for example, for JRuby. So what can we do with going back on the types? Here you can see what kind of types we currently support. These are just basic Ruby types that have very common representations in databases. So you have integer strings, but also floats. Big decimal is often used for decimal values, date, datetime, and true class for Boolean values. So those are actually 2 points that I touched upon. There's the single API, the native typecasting, but I think another really great value of the project is that we have what we call shared specs. And shared specs are actually a set of specs that define the common API that a driver needs to adhere to. So what you can see is, for example, I show you a very simple example. For example, if I want to create a driver for Postgres and I want it to a command, and I have a command object, and I want it to behave like a command object should, following the API. I can basically just say this. This already runs a few, I think currently a few like in the 10 or 20 tests against a command object, like does it respond to the correct methods, does it give an error when I give an invalid SQL query, and all kind of stuff like that. So what you can see here is the first step is it should behave like a command, and it actually just implements or it verifies whether you correctly implemented the API. The next line is something that verifies another option that's often supported with, I don't know if everybody knows about the issue with green threads, for example in Ruby 1.8, but also with native threads and the global interpreter lock in 1.9, is that when you run a query synchronously in a C-level driver, the whole interpreter does nothing else while that query is running. So you, for example, have a query that takes 5 seconds. Your whole Ruby interpreter, whether you use threads or not, doesn't do anything else during those seconds. But if your C-level driver supports asynchronous API, so if you can say to the C driver, just send out this query and I'll just check when the result comes back, you can actually improve on that. So even with green threads, then you can run multiple queries in parallel. So this spec actually tests whether your driver does that. So if you implement asynchronous I/O in your C driver, you can just include this spec and say, oh, I want to test whether it works. Oh, I just found the comment there. So there's not only the API that does this, but there's also a whole set of typecasting that can actually be verified. And you can see that here. What you can see here is that we use the big decimal. And again, we see two parts, because not every driver supports a type that looks like a big decimal in a database. For example, if you look at SQLite, it only has very limited types. SQLite only does integers, strings, nulls, and blobs. That's actually all it does. But still, you can use SQLite to serialize a big decimal to your database. What it then uses is a standard string representation, which is pulled back and can be pulled back later on as the same decimal. So that's actually what the first thing here specifies. It says, okay, we can deserialize and we can serialize big decimals into the database. It doesn't say anything on, about the specific type that is used in the database on how to represent that. That's actually what has been tested with the second part. That actually says, okay, we have a database. It provides a type that can be mapped to a database type. For example, most often it's called decimal. And it can use it to insert data and retrieve it, and it's stored in the database as a decimal value. So where are we currently? What do we support and what not? This is actually a very short map of what's currently supported. That's Postgres, MySQL, and SQLite. They have, I think at least, the easiest C APIs also, and are not the hardest to set up compared to a lot of more enterprisey database systems. We currently support any Unix platform, so maybe I should have put in the little red devil too. But and I also have been working on Windows support, so I'm going to release a gem, I think, today or early next week, that actually supports both MySQL and Postgres on Windows, because we already had SQLite, but this is a new thing I've been working on. And I really want to thank Luis Lavena for his work on being able to do that, because now I can just run on my Mac and say, I want to compile a Windows driver, and it just does it and it works, and I don't even need Windows myself, which is a really nice thing. So what could be a question is how could I help? So what is needed in the project, and what really could improve, in my opinion, the Ruby ecosystem in the area of drivers. That's, for example, improve transactions. We've abstracted a bit about transactions and tried to make them database independent and a full-fledged object that says, okay, I just want to start a transaction, I want to begin the transaction, I want to commit the transaction, or I want to abort the transaction. But it's already very simple, very rudimentary, and we would be great to improve on that to also, for example, work with nested transactions, different types of transactions, read locked, write locked, etc., etc. Another thing that could use improvement or needs to be added is the use of prepared statements. If you look back, you can see that you already can create a command object that actually executes. You can execute multiple times with different parameters, but it should be able to do that using actual prepared statements to improve performance there. Another main thing is specs. We could use way more specs to actually verify all kinds of edge cases, strange behavior, for example, with date objects, time objects, and datetime objects, because it's pretty messy in Ruby, and it's really hard to correctly do that and to be able to have correct time zone support, daylight saving time, etc., etc., etc. Another thing we would love to work on is an ActiveRecord adapter. There's also already a SQL adapter for DataObjects. The guy from SQL wrote that, so it's not a DataMapper only project anymore. But we'd love to have someone work on an ActiveRecord adapter and also be able to show and to realize that it could simplify the Rails code a lot in that area. And we really have the support of the Rails people that really want to look on it, but they don't have the time nor the priority of getting this high on their agenda, which I can actually imagine, because, well, it's in the state there. It works right now for them, so why change and put in all the effort, which can be, while it's being redirected mostly at the Rails 3 effort. And one of the last things we really should work on is support for more and different database systems. For example, Oracle, Microsoft SQL Server, IBM's DB2, and also for the people who know the logo, Firebird, for example. These are ones that I knew from the top of my head that at least I would like to have support, and I'd love to maintain them, but I don't have the expertise in each of these databases or all the time that I need to really start working on this. So actually that's the quick overview I wanted to give. I really want to continue with, I don't know, questions or maybe people who want to see stuff or how it works or whatever. So I just want to make it a bit of going back and forth here. So I don't know if there are any questions or people like to see code demonstrated or like to see how stuff works. There's a question over here? I don't know if there's a microphone or...
Microphone people are no problem. Sorry, because I missed the beginning of the talk. The motivation, sort of, instead of redoing this where DBI is already there,
yeah.
setting up to that, and what sort of problems you have with that. And when you were saying a demo, that would be, I would be
Yeah. Well, I can talk. I can share a bit, at least, about the DBI project. Is indeed it actually has the same goal, but the point is that I don't see it used very much, and I think that's the biggest problem with DBI is that apparently it didn't really succeed in the adaptation, and at least that this is already used for DataMapper. There's already a SQL adapter, and I think there will be a Rails and ActiveRecord adapter in the near future. So I think that's a big difference there, but I can probably show some stuff, some very simple stuff. Let's see. Gonna check whether I have a. If there are any other questions, please please go ahead. Let's see. I could probably show a bit of the. Where is, oh, there it is. This is what you see here as part of the specs suite. And is this readable or should it be bigger? Let's see, which is interesting, for example. Reader here, which you can see here is go to a more interesting example. Yeah, it does a query, it builds a query first here. Here you see, for example, select a code and a name from widgets, which is a table in the database, and it uses parameter binding to actually verify that it uses the correct argument. So it here retrieves the value. And you can see here that when you actually, here you can see it actually also runs the command, so it executes it. And down here you can see that when you loop through the list, the next function gives back a true or false whether there is any more results available. So if it's true here, you can see that the values actually are containing the data in there. So let me make some tables here. I should have prepared this part better. Let's get some tables in here. Are there any other questions or remarks or stuff that you say, why did you guys do this, or what question, yeah?
Yeah, it works. Yeah, I have a question.
Could you start?
Oh yeah, of course. Because earlier you mentioned the Rails people asking the question, why should we implement this when we already have something working? And I think that, as you said, this is something that is born from the need for it to exist. So maybe you could answer that question for them. Why should the Rails guys implement this in ActiveRecord?
It's not really a question of whether they should implement it or not. They actually are. They're very positive to the idea. The point is just they don't have the time or the resources at the moment to really dedicate their time to it. So what you see is that there are few people who've also given out their or showed their interest into this. What we try to do here is support those people and get them to work on it and be able to do that.
I actually mean, does it make Rails more flexible to port to other databases, or does it make it faster?
I think it's one of the major efforts is maintenance, code maintenance. It greatly simplifies the code. You have a lot of less code that needs to be specific for each database, so you can share much more code in reality than there is. For example, I know the details of the DataMapper project, and actually what you see there is that the drivers. There are driver parts for example, Postgres and SQLite and MySQL, but what you see there is the only thing they do is actually behave slightly different because of the variations on the SQL dialect. The central DataObjects adapter just generates and works through the DataObjects API and generates ANSI SQL, and only the database drivers beneath it only extend the basic driver and change minor things that actually show how to do that. So I think that's by far the major advantage. Another advantage could be for example the performance. If you have a table which uses a lot of objects like decimals or dates or whatever, they're constructed in the C driver, so that could probably be faster than with ActiveRecord. But that also kind of depends on if you, for example, load up an entire table, but you don't use a certain column, which is, for example, a type of date, then it will be. Okay, then it will be probably slower because it has to parse all the dates and not just keep them as strings.
Okay, thanks.
So there was a.
Hi. I was working with JRuby in January, and as far as I see it, DataObjects doesn't support JRuby at the moment, but there's an effort to port it. How far is it?
It's pretty far along. Whoa, shit. Sorry. The current state is that there's someone else working on it. I don't have the real Java expertise, and he's doing that, and he got the MySQL part is actually working, and the other parts are, for example, the Postgres is near completion. SQLite is a bit of a problem because the JDBC driver for SQLite is not very good and doesn't really support everything you would want from it to support. What we probably do is, instead of that, for JDBC support stuff like Derby or H2 for JDBC. But we could really use some help in that area, and also to test more against it and to run that stuff. So if you think, if you're interested, you can always talk about it later or something.
Yeah, I'm not doing that anymore, so.
Oh, okay.
Thanks.
More questions? Good. Thank you.